Hello everyone, this is Jennifer Rose, Assistant Professor of Mathematics, Theivanai Ammal College for Women, Villupuram. We are discuss about the topic is differential equations. So what is the differential equation? Differential equations were begun by Newton and Leibniz in the 17th century. So differential equations are often used in economics. So this is applied in the economics. And a differential equation is an equation that involves derivatives. So more are using the derivatives, and it is implicit functional relationship between variables and their differentials. The unknown is often a function of time. So next, definition of the differential equation. A differential equation is a relationship between an independent variable x, a dependent variable y, and one or more differential coefficients of y with respect to x. For example, x square dy divided by dx plus y sin x is equal to 0, and xy d square y divided by dx square plus y dy by dx plus e power 3x is equal to 0. So these are the examples. Next, the classification of differential equations. So there are two types of differential equations. One is ordinary differential equation, another one is partial differential equations. So ordinary differential equation involving ordinary derivatives of one or more dependent variables with respect to a single independent variable. So involving only one independent variable. So this is the ordinary differential equation. So partial differential equation is involving partial derivatives of one or more dependent variables with respect to more than one independent variables. So two or more independent variables involves in the partial differential equation. So this is the difference between the ordinary and partial differential equations. Definition of the order and degree. So is an important role is order and degree. So the order of a differential equation is the highest order of any of the derivatives contained in it. So order is, which means that a differential equation is of order n if the nth derivative is the highest order derivative in it. For example, dy by dx is the first order, and d square y divided by dx square is the second order, and d power 3 y divided by dx cube is the third order differential equations. So another one is degree, the highest power to which the derivative of the highest order occur is the degree of a differential equation. So highest derivative power is, which means the degree. So for example, y is equal to dy divided by dt plus t square. The equation order is 1 and the degree is 1. The another example is d square y divided by dt square the whole cube minus 6 dy divided by dt the whole square plus ty is equal to 0. The order is 2 and the degree is 3. So highest order is d square y divided by dt square, and the power is 3, which means the degree, highest degree. So this is the difference between the order and degree. First order differential equation. There are 4 types having the solving differential equations. Method 1 is direct integration or elementary differential equation. The simplest form of the first order differential equation is dy by dx is equal to f of x. This can be solved in principle by integrating f of x that respect to x. So then we'll be getting the answer is y is equal to some value. So next one is method 2. By separating the variables, consider the equation of the form. This is the also called as variable separable method, and the form is dy by dx is equal to f of x divided by g of y, or dy by dx is equal to f of x into g of y. The equation in which the right hand side can be expressed as product or quotients of functions of x or of y. The equation of the form is dy by dx is equal to f of x divided by g of y. Then we will g of y, the denominator of right hand side value is going to other side. So we get the answer is g of y dy is equal to f of x dx. Then we'll be integrating the values with respect to the y or x. So then will be integration of g of y dy is equal to integral f of x dx. Then we'll be integrating the answers. For example, finding the general solution of the differential equation 3y square y dash is equal to 2x minus 1. So y dash means dy by dx. So 3y square dy by dx. So dx, the denominator dx going to other side. So then will be get 3y square dy is equal to 2x minus 1 into dx. So when we integrating the answer, we get the general solution. So another example is also, and the method 3, linear equations using the integration factor. So linear equation of the form is dy by dx plus p of x y is equal to q of x. So this is the form, this type of equations. Then will be solving method. To solve any such equation, we multiply both sides by an integrating factor. So integrating factor means if or I of x, which is always e power integral p of x dx. So e power p of x. So question, we have the question having the p of x answer and also q of x value. Then we'll be substituting in integral p of x dx, then integrating the value. After we substitute the integration. So e power integral p of x dx dy by dx plus e power integral p of x dx p of x into y is equal to e power integral p of x dx into q of x. Then we get the answer is y into integrating factor is equal to integral q of x into integrating factor dx. Integrating factor is e power integral p of x dx. So what is the value is y into e power integral p of x dx is equal to integral q of x into e power integral p of x dx. So examples are y dash plus 2xy is equal to 4x. So this type of equation, the what is the form is dy by dx plus p of x is equal to q of x. So this example, what is the p of x? 2xy. What is the q of x? 4x. So we will substitute the values and we get the general solution. Next the method 4, exact differential equations. So exact differential equations of the form is m of x comma y dx plus n of x comma y dy is called an exact differential equation form. So this is the we having the equation. So then will be how to solve this equation and we get the general solution. Now we are going to see about this in a domain D. In a xy plane, if there exists the function f of x comma y called the potential function, df of x comma y is equal to m of x comma y dx plus n of x comma y dy for all x comma y in D. So we are now going to see about the how to change in case non-exact differential equation. Then will be how to change the differential equations. So first theorem is m of x comma y comma n of x comma y dou m by dou y comma dou n by dou x continuous functions in a domain. The first order differential equations m of x comma y dx plus n of x comma y dy is equal to 0 is an exact differential equation if and only if for all x comma y in D. So dou m divided by dou y is equal to dou n divided by dou x. So m is the value, m value partially differentiating with respect to y, and n of x comma y is partially differentiating with respect to x. We get the values are same. So then will be that equation is called exact differential equation. So otherwise that differential equation is called non-exact differential equation. So which means that m of x comma y dx plus n of x comma y dy is an exact differential equation. Then the equation m of x comma y dx plus n of x comma y is equal to 0 is called an exact. This is also an definition of the exact differential equation. So the problem solving condition is this one. So dou m divided by this, that equation is satisfies dou m divided by dou y is equal to dou n divided by dou x, which means that exact differential equation. This is the solving method of ordinary differential equation. So next, these are the examples. So first one is 3x into xy minus 2 plus x square plus 2y dy is equal to 0. So another one is xy dash minus y sin x plus 1 is equal to 0. So we check the differential equation exact or non-exact. Then we will find out the general solution. Thank you.